Hello everyone, my name is Amrita Bhatnagar. I am Assistant Professor in Department of Computer Science in AKG. Today I am going to give you a good explanation about the bus arbitration techniques. So let us start. This is a very good topic of COA, Unit 1. Let's start. First one is Introduction to buses. Firstly, we have to understand what is the buses and what is the use of buses. Why we use these buses in our digital computer. Now, next is different types of buses. Different type of buses can be in our system and the responsibility of each and every bus is different. So, then we understand what is the meaning of different types of buses. Now, next is bus architecture. Bus architecture means how these buses are connected to different devices like computer CPU and memory and input output devices. And last one is our bus arbitration techniques. So, these are the topics which I want to discuss in this lecture. Okay. Now, first topic is Introduction to buses. Introduction to buses. Firstly, we have to understand what is the meaning of buses. Buses are used to transmit the data from one part of the computer to another part of the computer, and these buses connect to each and every component of the computer. For example, if I want to, this is my first device A and this is the another device B. These are two digital component device. Now I want to send the data from the A to B, or if I want to send the data from B to A. So to connect these two devices, I need a buses connection, which is a communication path between these two devices. It is a shared communication path between different components. So you can see here, A can send data from this side to another side to B, and B can send data from A to B. So this is our introduction of our buses and uses of buses. Now next, different types of buses. We have buses, but there are different type of buses also there. We have different buses for the different purposes. So we can see here different types. First one is data bus, second one is address bus, and third one is control bus. Fine. So these are the three different types of buses. Now the question is, what is the role of these three different types of buses? Why we use these different types of buses? Data bus. Data bus is required to send the data on the different device like memory unit, input output device and processor. So we have data buses to send the data from one device to another device. Data means which is stored in the memory. For example, this is your memory and the data A is your data, and to send this data from one device, for example memory, to CPU, we need data buses. And the another thing is, data bus are bidirectional. Why it is bidirectional? Because we can send data from the one device to the another device. For example, if we have two devices, CPU and memory, then CPU can send the data to the memory, as well as memory can send the data to the CPU. It means we have, it is a bidirectional device, bidirectional buses. So data bus will be always bidirectional. We can send data from the one device to the another device. Second one is address bus. Address bus, it carries the address of data between memory. It means this is address, not data. Now, what is the meaning of address? We should understand. If this is your A is your data, then this is your address. If we have some memory location of this, for example, this is 1010, 1010 is your address. It means this is the address, and this address will carry by the address bus, and data will be carried by A by the data bus. So, this is the difference between data and address. And the last one is your control bus. Now, what is the meaning of this control bus? Why we use this control bus? Control bus meaning it will send data, or it will carry data from one device to the another. Which data? Which information? Control information. It will send control information from one device to the another device. Now the question is, what is the meaning of control information? Control information meaning the signal which is generated by control signals are known as a control information. You can say name, memory read, memory write, all these are our control information or control signal. So, these control signals are generated by our control unit, which is the part of our CPU. Okay. So, these are the different types of buses which we use in our digital computer system, and these have different rules, different type of information carriers. Next, bus architecture. Now, we will understand what is the meaning of bus architecture and how we can connect these buses with the devices. Okay. Now, you can see this diagram. This is the diagram for the bus structure or architecture. We can see here, this is the common bus path. We can see here, this is the bus common path, control line, address line and data lines. This is the common path, and all devices like input devices, memory, processor and different devices are connected with this common communication path. You can see here, at a time only one can, because this is the shared medium, then that's why only one device can send the data on the buses. So, every device have to wait for its turn. Each and every device cannot send simultaneously data on the buses. It is not possible. So, each and every device have to wait for the turn. Now, the question is, who will decide it? Which device will send the data? How it will be decided? That's why there is a need of a bus arbitration techniques. Now, bus arbitration techniques. Why it is required? It is required because we have buses as a shared communication system. Shared means all devices will share a particular communication path, and we have to give turn to each and every device. This is the definition of bus arbitration. Bus arbitration is the process by which the next device can be given to bus master is selected, and the bus mastership is transferred to it. The selection of bus master is usually done on priority basis. The device that is allowed to initiate data transfer is known as a bus master. In a computer system, there may be more than one bus master. For example, a processor, a DMA controller, etc. can be a bus master. They share the bus system. When the current master relinquish control of the bus, the another bus master can acquire control. This is the main thing. So, one bus master will relinquish the control of the bus, and another bus master can acquire control of the buses. Now, different bus arbitration technique. So, we have understand till now why we use bus arbitration technique. We use bus arbitration technique because we have shared communication path and we have to give turn to each and every device which is connected to the buses. So, we have to give turn. That's why we have different technique of bus arbitration. There are mainly two approaches for the bus arbitration. First one is centralized bus arbitration. In the case of centralized bus arbitration, we have a centralized bus controller which will decide which device will send the data on the buses. Now, centralized bus arbitration can have three process or methods: daisy chaining method, polling method, and independent requesting method. So, these are the main methods for bus arbitration. And the last technique is distributed bus arbitration. Distributed arbitration means when there is no one controller for controlling all this process. Okay, so let's start with daisy chaining method, centralized bus arbitration. You can see here, this is a diagram for daisy chaining method. You can see here there is a one controller and there are n masters for the buses. N master means these are the devices which can use shared bus systems. Fine. But at a time only one master or one device can send data on the buses. For this process, these devices will send the bus request by the help of bus request signal to the controller. So, we can see here in this case we have only one bus request signal. By the help of this bus request signal, this masters can send their request to the controller. Now, what controller will do here? Now, controller will check the bus busy signal. The use of bus busy signal is that if this bus busy signal is inactive, it means buses are now not shared by the any particular device, not using by the any particular device. So, it can be granted to other device. The controller firstly check the bus busy signal. If it is inactive, it means bus can be granted to other devices. So, controller will send bus grant. Controller will send bus grant to first master 1. If master 1 wants to send the data on the buses, then it will keep its token and send and become the bus master and send the data on the buses. And it activate the bus busy signal 1. It means now bus master is using the buses and no other device can send the data this time. So, this master will active this bus busy signal. Fine. Now, next, when this device will send a request, send the data on the buses, after that it will send the grant to the master 2. Then master 2 will keep the token if it wants to send the data. If it don't want to send the data, it will send request to the other device. In this way, this daisy chaining will work. So, you can see here this is the signal is serially propagated in the daisy chain, and every time each device will have a particular token. If the token, it will get token, then it can send the data on the buses in this way. So, but this in this case there are some disadvantages, some advantages, but we have also some disadvantages also. So, we should again see these things. Daisy chaining method. What is the daisy chaining method? It is a simple and cheaper method. All master make use of same line of the bus request, that is okay. In response to the bus request, the controller sends a bus grant if bus is free. Fine, we send the bus grant signal for if the bus is free. The bus grant signal serially propagates. In this case, we say grant signal is propagated serially. Therefore, any other requesting module will not receive the grant signal. hence cannot get the bus. If the bus line signal is busy, is active, then no other device can send the data on the buses at that time. Now, so what are the main advantage of daisy chaining method? First one, this is a simple circuit. We have simple circuit. There are no many connection lines are there. So that it is a simplicity. This is the main advantage of daisy chaining. Less number of control lines. We have only 3 control lines: bus grant, bus busy, and bus request. The user can add more devices along the change up to a certain maximum value. So we have in the diagram we have n devices. We can add more devices also very easily in the case of daisy chaining. These are the main advantage of daisy chaining method. Now the disadvantage of daisy chaining method. Priority assigned to a device depends on position of the bus master. So if we can see here, only here the priority assigned by the position. For example, the device which is connected to near to the bus controller, for this device will get priority first, and other device will get priority in the last. So there is not dynamic priority possible. This is only the static priority. It means device will get the priority according to their hardware connection, which is a drawback of this technique. Propagation delay arises due to serially granting of request, granting of bus. This is the main reason of propagation delay. It will slow. This is the slow method. If one device fails, then entire system will stop working. It may say, we may say that poor fault tolerance is there. If one device will fail, all the system will stop in this daisy chaining method. So these are the main disadvantages. Because of this disadvantage, we have to go for the next technique, which is known as a polling method. Now, what is polling method? This you can see, this is the diagram for the polling method. Again, in this case, we have one controller and n masters or n devices which wants to send the data on the buses. In this case, again we have one bus request signal by which all the devices can send the data or send the request. And we have also a bus busy signal and bus request signal. Fine. Now, in this case, we have n polling lines. We don't have here bus grant signal. We have here polling lines. In these polling lines, controller will send the address of the bus master. For example, we have here 3 devices. Okay, then controller will send the address of the one device 0001. If this is the address of this device, then this is the turn of this device to send the data, and other devices will wait here. So only the controller will decide here which device will send the data by sending the address of the device. So we have here different addresses of the each device, and what is the number of polling devices will be there. For example, if we have 4 devices, it means there will be minimum 2 raised to power 2 minimum 2 polling lines here. In this way, when the number of devices will increase, then number of polling lines also increases. So we can see in this method, again I am repeating the method of polling method. In this, the controller is used to generate the address of the master. Number of address line required depends on the number of master connected in the system. For example, if there are 8 master connected in the system, at least 3 address lines are required. In response to the bus request, controller generates a sequence of master address. When requesting master address recognizes its address, it activated the busy line and begins to use the bus. Now, the advantage of polling method. Polling method is dynamic priority is possible in the polling method. Dynamic priority means we can give priority to any device. If n devices are connected in the system, then we can give the priority to any device. It depends on the, does not depend on their hardware connection. So we can say that it overcomes the drawback of the daisy chaining method. If one device fails, then entire system will not stop working. This is the main advantage. So in the polling method, we don't have disadvantages or drawbacks of the daisy chaining. But there are some disadvantages also there in the polling method. What are these disadvantages? The main disadvantage in the polling method is that adding more devices is difficult as it increases the address of line of the circuit. It means we can't add more devices in the polling method, because if we add more device in the polling method, it will increase the number of polling lines. For example, if we have 4 devices connected, then we have only 2 polling lines. If we have 3 connected, then we have only, if we have 8 connected, then we have 3. So we can see here, if the number of devices increases, then number of polling lines also increases here. So this is the main disadvantage of the polling line. We can't, it is difficult, or we can say it is difficult to add more device, because it becomes the system very complicated and costly. Now the last one is independent request method. You can see this diagram, independent request method. In the case of independent request method, we have one controller and master devices. But the difference is there, we have bus grant and bus request signal for each and every master or device. Here again we have only one busy signal, but we have different bus grant and bus request signal for each and every master. So you can see here, each and every device can send request with its own connection to the controller, and bus grant will be available by the help of its connection. So it will be a fast response. Master should not wait. So this is the scheme where the working is very fast. But we can see here, we need many connection. If the number of devices are more, then number of connection will be more in this case. But it will be a fast technique. In this scheme, each master has a separate pair of bus request and bus grant lines. Each pair has a priority assigned to it. The built-in priority decoder within the controller selects the highest priority request and assert the corresponding bus grant signal. Now, advantage of independent request method. What are the main advantage of this method? Fast response, because we have different connection for the grant and bus request, then fast response will be there. Speed independent of number of devices. तो स्पीड भी इंडिपेंडेंट होगी, स्पीड क्योंकि हमारे पास because we have different grant and request signal, that's why speed will be independent of number of devices. Now disadvantage of independent request method. The main disadvantage of this method is hardware cost is high as the large number of control lines are required. As the number of control lines are required or increase, the hardware cost is increased. So, this is the main disadvantage of independent request. Next, connecting a large number of devices is difficult as it increase the more control lines. Again, in this case, we can't add more devices. A number of large number of devices we cannot connect in the independent request method, because it will become more complicated the circuit. Okay, so these are the main techniques of centralized bus arbitration. Due to this disadvantage, we have another method also, which is known as a distributed arbitration method. In this distributed arbitration method, all devices participate in the selection of the next bus master. It means we don't have centralized controller. In this case, all devices are communicating to each other and decided which device will send the data on the buses. So, this is known as a distributed arbitration technique. Okay. So, now we have covered all the different arbitration technique. Thank you.